require human intelligence, or where it involves so much data that it would be impossible for people to analyze manually. It's a bigger and more general term than machine learning, and it covers lots of different functions people may use today. For example, AI already improves the way we use maps and navigate around the world, and it also helps with your social media recommended content based on your interests. Machine learning is actually a subset of AI, and it is how the machine learns. Machine learning gives computers the ability to learn without explicit programming. Often you'll hear the term AI, and it's actually the machine learning that's providing this magic box that we're thinking of. Machine learning requires large amounts of data and computing power. It uses algorithms and statistical models that enables the machine to learn to offer predictions or make decisions based on the data that it's trained on. Sometimes the distinctions between AI and machine learning can become a little bit blurred. So we talk about AI when we're actually meaning machine learning, but just to clarify that, machine learning is how we get the machine to learn. So it's how we bring about a system that ultimately AI is using. So to talk about machine learning, it is everywhere around us. It's in chatbots, it's in our social media content recommendations, and really excitingly, it's also being used, for example, in medical diagnosis. So it's helping doctors identify diseases by analyzing X-rays and identifying complex patterns in radiology data, for example, to speed up that diagnosis process. You'll also see AI is being used in a lot of what Google does. So if you've ever used Google Flights, it will give you an estimated carbon emission for every single one of the flights that's been aggregated, so that you can make an informed decision when you're booking your trip. If you use Google Photos, you'll notice that AI-powered features like Magic Eraser, which can get rid of those unwanted artifacts in the background so that you can focus on your family. It's really it's so simple, just a few taps to get rid of them. Another place you'll have witnessed it is in Gmail, where in Smart Compose you can literally tab to complete a sentence as you're writing the emails, which I think is really fascinating. So machine learning is providing that, and the way that it does that, key to all of this, is data. Machine learning requires lots of it to discover connections and correlations in that data set. The data must be collected and then processed to ensure it's of good quality, and once that's occurred, machine learning systems need to be trained and then evaluated to make sure that they're actually giving useful predictions. The more it works with the data, the more the machine learning system can actually continuously evolve, gradually getting better and better. The machine is literally learning. So without machine learning, why do we need it? We could just hire a programmer to write lots of code to analyze the data manually, but this can be costly and time consuming. For example, imagine we had a mobile app and we wanted on this mobile app to push different products to the users based on the weather patterns. So it's summer, you want it to push caps and sunglasses, sandals and tote bags, which is all very well. So why not just get a programmer to develop this themselves? Well, the problem is you might have thousands of products in the system, and you've got to add in this new logic that says, well, if it's a warm weather product, go and put it in this bucket, make it appear in these ways. So you get this if statement, but everything in your database needs to be added this new information. Is this warm or is this not a warm product? So you've got this new column in your database. And then somebody says, oh, can we actually also have winter promotions? So now you've got to associate cool weather things. You're trying to make decisions about the data every time. And so this code gets more and more complex over time, and that time and complexity leads to an inability to actually adapt to the changing environments. For example, maybe you just want to have sales at different times of the year, not based on weather patterns. And suddenly everything gets really complex. And that's where machine learning can really help, because what you're trying to do is identify patterns in the data and then get the system to work out those complicated scenarios to ensure that the user gets a really good experience. Machine learning can constantly learn and improve. Cool. So let's look at some really good problems that we can actually look to solve with machine learning. Now, I like to split machine learning into two main functions. First, you have predictive, and this is where you are trying to make predictions about future events or outcomes based on historical data. Think about weather forecasts, for example. You can identify the weather patterns, you can see what that might mean in the future based on the history, and therefore predict what might happen in the future. The second that you've probably heard about much more in the news recently is generative AI. This is where you are trying to use existing data to create new data. For example, generative AI tools can create new images, new text, or music. Generative models are often trained on huge data sets of existing data, and then once they're trained, they can be used to generate new data that is similar but not the same as the data it was trained on. So if you've used Gemini, you can create email templates for you to edit. Gemini also has Imagen 2, which allows you, or 3 if you've got the pre-release, which allows you to generate images on the fly. There's even a video model that's in the works. So it really, depending on the problem that you're trying to solve, dictates what sort of model you need to actually generate the new things. So, as you can understand, when you're trying to solve problems using AI, it's really important to define a distinction between predictive and generative solutions. Good examples of problems you might want to solve with machine learning. Creating content, that's very much in the generative space. Forecasting, that's more predictive. Classifying images, that's also predictive. You're kind of labeling things, and then you can predict what the future labels might be for certain images. Customer service is quite interesting because you're trying to predict what the customer needs, but then generate a transcript to actually have an engaging conversation with them. So it sort of straddles both generative and predictive. Security is more in the predictive space, but I've also seen people use generative AI to help with that. And also productivity. So if you're trying to create lots of AI generated images, obviously you want generative AI models. So another thing we should also look at when we're trying to take steps towards using AI is what is actually a good problem to solve using machine learning. So firstly, and this goes with pretty much any problem that you're trying to solve anyway, what can you define what the goal is? What does success look like for you? For example, if you are building a customer service chatbot, it's important to work with a data scientist and give yourself a target. You know, we want to solve 50% of the customer queries coming in using AI. So now you've got a number that you can actually try and achieve to. And as you're training the model, you know when to stop training because it's good enough. Or maybe you want to carry on training because you still think there's more progress that can be made towards that target. Secondly, do you have the right data? Bear in mind, machine learning takes up a lot of data. At a minimum, you need a few thousand data points, but many systems will use millions of data points to give accurate answers and results. For example, banks use machine learning built on the data of millions of transactions to help them detect fraud in near real time. Another consideration to this is cleaning and labeling the data, which kind of goes on to the third thing, which is, do the benefits outweigh the resources to implement the solution? Data scientists, it's a really in vogue job role right now. So people trying to do data science are obviously demanding a lot more money. So a team of experienced data scientists is going to cost a lot of money. You can make do with some of the resources that I'll be sharing throughout this pack. But one of the things I like to say to people is, have you optimized your non-AI solution first? Sometimes we can actually make do with using things like Google Sheets or Excel to just manipulate the data and look and try and doing things ourselves. So do consider optimizing your non-machine learning solution until it's evident that to make any progress, you need to reach for AI. And a great example of this is a tool. It's a tool called Simple ML for Google Sheets. You can install it right away. It's an add-on for Google Sheets made by Google, and it gives you some of the most common ML tasks: predicting missing values, spotting abnormal values, and forecasting future values. I don't know if you've ever got an Excel document that's maybe an accumulation of all your sales data across various parts of the business, but there's one row that's missing, or maybe one person has put the decimal place in the wrong spot. And this tool is perfect for that. As long as you've got more than 50 rows, I think it is, it might be 500, it will be able to tell you if there's an abnormal value there. It will basically say, oh, this row, there's a 90% likelihood that it's not the correct value. And then you can go and have a look at that row and go, oh yes, I can see it. So it's really good for identifying things which you would typically solve using machine learning, but it does it in a nice, approachable way. So do check that one out. And thank you, Daryl, for sharing that link. Another thing that I'd love to talk about is the ethics behind using AI. Google have AI principles, so Google is committed to using AI responsibly. In fact, back in 2018, when Google first shifted to becoming an AI company, it has created this principles framework to basically ensure that everything they produce goes through a governance structure and an ethics review process. And it's just good values like be socially beneficial, avoid creating and reinforcing unfair bias. A lot of these things are incredibly useful when thinking about AI. So when you reach to make something using machine learning, do ground it in principles, should you be doing the thing that you're just about to do. Okay, cool. We've got the preamble done. So we're actually going to look at some real machine learning models now. I've broken them down into 3 areas. So these are in the predictive space, not the generative space. And that's, we're going to be focusing on supervised learning, which is training with label data. I'm going to talk a little bit about unsupervised learning, which is training with unlabeled data. And then I will talk about reinforcement learning, which is getting the system to train itself without any data. But Adam, didn't you say that you need lots of data to do machine learning? Cool, that's good. Hold on to that thought until later. Okay, so the first one is supervised learning. And the best way to articulate this is my favorite example. It's Muffin versus Chihuahua. So the concept behind supervised learning is you get a data set with lots of images, for example, or it could be anything that you want to label, and you're trying to identify the difference between, in this scenario, a dog and a muffin. But they look so similar, don't they? The way you would do this, you don't actually have to tell the machine, like, this is what a muffin looks like, this is what a chihuahua looks like. All you do is you say, here are a load of images, split the data set into half. Say, here are a load of images. The first one, this one's a muffin. So let me just do that. So got the laser pointer. This one's a muffin. This one's a muffin. And this one's a dog. You label them one by one. It's an extensive process. It can take a lot of time. But ultimately, you have labeled 5,000 images and said whether they are a muffin or a chihuahua. And then you get the second half of your data set and put them in one by one. You perform some training first, and then you put them in one by one. You go, what's this? And the machine says, 90% likelihood that this is a dog. Great, you've got something that works. And then the more things that you can test it on, the more you know the algorithm is working. And that's why you typically split it into two, and that helps you understand whether you've actually trained the system correctly or not. And if you want to try this at home, you can actually do it straight away by using Teachable Machine. So I'm actually going to demo this right now for you. I'm going to do this. This is the first time this has ever been demoed in this structure. So let's see how we get on. So hopefully you can see this. What we're going to do is an image project, just a standard image module. And I'm going to train it the difference between me and not me. And what we'll do is we'll get the webcam, and every time I hit this, these are loads of images of me. I'm going to do some waving and all sorts. There we go. So there we go. We've got lots of images of me in the system, and then we've also got to tell it what it might look like if we didn't have me. So there we go. There's 31 images that don't have me. I'm going to train the model. And so this is doing lots of number crunching in the background. Sorry if it all goes out of sync. As you can see, it's training lots of epochs, they're called. And this is now a live system of AI that has been trained as you were watching. So as you can see at the bottom here, it says me, and it's 100% certain that this is me, okay? But if I go like this, there we go. It's 100% certain that's not me. I come in again. It's me. It knows. It knows. It's magic. It's not magic. It's machine learning. So there you go. That is as simple as it is to do your own machine learning project. That's called Teachable Machine. Just going back to the slides, you can get to it by going to teachablemachine.withgoogle.com. So do check that out. I'm just going to stop that in the background because I don't want it eating up all my CPU in the background. So do check that out. It really is easy to do. Okay. I don't have demos for these other ones, so you'll just have to trust me. But for unsupervised learning, we want to do some training with unlabeled data. So we're not specifying the difference between me and not me. We might have, for example, a lot of customer data. And this is showing how much people have spent on our website and at what time of day they were spending it. And what we want to do is we want to ask the machine, what are the patterns? And what it does is it can go away, crunch all the numbers and look for the different columns in the data set that you shared with it and look for patterns and correlations. In this particular one, it's identified that people who spend more time on the site are also spending more money on the site, which I think is quite interesting. So the amount of time that you spend on the site, the more money that you spend. Or maybe, in another world, it's the time of day that you connect to the site. The later in the day it is, the more money you spend. Now, what unsupervised learning is, you're just saying, here's a data set. Maybe there's 20 columns worth of data. Can you identify the pattern in this data? And so it looks for correlations. Now, correlations aren't causation. So that's one thing I would say. And what I mean by that is, just because people are spending more on the site at later points in the day doesn't mean if they come to your website, they spend more money. It just means that there's an interesting pattern. So it can allow you then to experiment and say, okay, what happens if we do a sale first thing in the morning? So if you join on the website before 10 a.m., then you get a discounted price. Will that actually encourage people to spend more money at that time? And then if you do another sale after 10 p.m., do people buy more in the one later? So it might give you a correlation, but then how you act on that is up to you as a company. So that's unsupervised learning. And you can do that using Google's Vertex AI Studio. So there are ways to do this, but I don't have a demo for you, I'm afraid. The last one is reinforcement learning, and this is where you get the system to train itself without any data. A perfect example is, let's say you wanted an AI to be very good at playing chess. What you would do is you would give it the kind of rules, like a grid of all the pieces, and every time it makes a good move, you reinforce it. You say, that was a good move. Every time it does a bad move, you say, wasn't such a good move. And you give it the goal of trying to maximize the amount of good that it gets as it plays the chess. Now, you play it at chess and it will lose because it doesn't know how to use the pieces properly. And when it does move the pieces, it kind of moves them in a crazy manner. But then you play again and you play again. And you keep on playing it again and again and again, thousands of times. Then you might even get the AI to play itself. So different versions of the AI, every time it's getting better, and every time it gets better, you reward it. So then it reinforces that behavior. And what emerges after 1 million games that it's played against itself is an AI that can actually beat human beings at playing chess, as has been done in the past. And so examples of reinforcement learning that you could use in your business: optimizing food recommendations. So let's say you have a mobile app where people can order takeaway food. They try to, or you offer to offer a burger to the customer, but the customer doesn't order a burger. So they see the offer and they go, nope, don't want that. So in the future, you decide to offer similar demographic a pizza, and they do buy the pizza. So now you've got information that says this type of demographic is more likely to order pizza in these particular scenarios. Do that with thousands of customer orders coming in, and suddenly you've got a recommendation engine where you are more likely to offer pizza for this particular demographic. And hopefully then that reinforces the good behavior. And if suddenly people find themselves ordering different foods, that service can react to itself. It reinforces the good things that seem to be successful, and it tries to negate the things that don't end up in that successful order. Oh, yes, cool. That's it. So jumping, let's test your knowledge. I'm afraid there isn't a certification for this particular quiz, Buella, but let's just play it for fun. So you're devising a navigation system for robotic trucks to navigate the factory floor. You want to find a way of determining the most efficient path through the factory. However, the factory layout may change in the future. And I want you to tell me, just by typing into the chat, whether you think it's A, supervised learning, B, for unsupervised learning, or just type C for reinforcement learning. So a robot navigating the factory floor. Has anyone got any ideas? Oh, there we go. Cool. So we've got some ideas coming in. We've got reinforcement learning. We've got some people saying supervised. Some more people saying reinforcement and supervised. Cool. Right. Well, for the people who said supervised, I understand why you've said that, because you might be wanting to do a vision system and saying, okay, label this as a floor or a wall, and do some sort of supervised learning there. But it's not what you would use in total. So it may have aspects of supervised learning, but generally we're looking for reinforcement learning, especially reinforcement learning where you're not letting it loose on a real factory. You want it to work in a simulator, crashing into things all the time in the simulator until it gets to the point where it's not likely to crash into things. So reinforcement learning is the correct approach. You might have aspects of A and B, in fact, but C is the correct answer. So well done to all of you. There was about 20 of you who got that right. So well done. This is good. This is a really good group, Daryl. Where did we find this? Right, cool. The next one, we've got a business providing custom photo gifts. We want to determine whether the quality of the uploaded customer images are high or low quality. Let's say we're printing them out, so high quality images are more likely to be useful. We already have a huge database of past images that have already been classified. So the question is, should we be using A, supervised learning, B, unsupervised learning, or C, reinforcement learning on this particular custom photo gifts? I'm just going to go on mute while people think. Yes, everybody's right. Excellent, you are correct. Well done to all of you. It is a supervised learning. So just to reiterate, you don't need to be doing just images to do supervised learning. It can work on audio, it can work on text. I've seen it used where they have got reviews in every day and they label whether the review is well written or not well written, and then they have an AI decide and do that editorial thing before they put the reviews on the website. So it isn't just photos, can be text, can be audio. In this particular scenario, it is photos, and A is correct. It is supervised learning. Excellent. Okay, last one. And you've been doing so well. You folks need a round of applause. Okay, the last one is identify the type of machine learning system. You have a lot of sales data and want to invest in some marketing activity. You want to identify 2 different demographics from your history to run some targeted adverts on. Is that supervised? Is that unsupervised? Or is that reinforcement learning? So A is supervised, B is unsupervised, and C is reinforcement. And look at this. I hope you're not just saying B because it's the one we haven't had. And you're saying it because it is indeed the correct answer. So in this particular scenario, you do want to do unsupervised learning. Once again, I would say understand people who understand the business. It's really good to have them in the room as you're getting your results from your unsupervised learning. It might tell you something really random, like the people who have D in their name are more likely to order this type of product. And that might be true based on the data, but it doesn't actually work out. There's no reason behind it. So it's good to have once it's decided what those patterns are, have people from the business look at it. And if it tells you something like people who are based in the south of England are more likely to buy this certain type of product, then you might actually have a specialist within your business to articulate why that could be the case. So it's really good to do this machine learning and utilize the people in the business to understand what that means for your company. Excellent, you're all doing so well. So this is really good. Next, we'll move on to preparing data for machine learning, because clearly you all are able to start your first machine learning projects. If you want to prepare your data for machine learning, first you need to rate your data, RATE. That's an acronym that I put together that helps you identify whether your data is ready to have machine learning run on it. The first thing is representative. So, does your data set contain any unusual anomalies that could skew the results? For example, imagine you're a hotel chain and you've got customer data that you took during the pandemic, for instance. That information is going to be very different customer behavior to both before and after the pandemic. So if I was working with a hotel chain to do some machine learning on its data, I'd probably suggest to remove the 2 years that were during COVID and maybe even consider removing everything before, so that you really only focus on what is representative to how your customers behave at the moment. The second one is abundant. I've said this before, but you need lots of data to do machine learning. The larger your data set, the more accurate the results are going to be. Remember, if you're doing something fairly trivial, then consider using Google Sheets rather than doing something that requires machine learning. The next one is trustworthy. So if you don't trust your data source, then you're going to make a very expensive thing that you don't trust by putting machine learning through it. So if, for example, you've got web analytics data on your website, but you know you never really set up the web analytics properly and it's not really capturing all the orders, well, you're just going to have a very expensive system that doesn't really indicate what has been going on before. So it really is important, if you're starting a machine learning project, is get some of the key stakeholders from your business in a room to look at the data set before you do machine learning and say, do we trust this? So audit your data for accuracy before starting machine learning. And lastly, most importantly, the E in RATE stands for ethical. It is vital that you have legitimate use of your data that you're training on. The data is indicative of the demographics you're going to be creating models for, and that you anonymize the data before running it through trainings. That means taking out personally identifiable information like names or email addresses, or even if you've got people's accurate location, that can be a bit of a grey area. So I like to anonymize things to a general bucket. So for example, if I'm doing something that contains location data, rather than having a pinpoint of the person's house, I say they're in this area. So you can define how big your areas are. It's just try and think of things in an ethical sense. Right, sorry, I can see some questions coming through. If machine learning is able to understand patterns and data sets, can you train machine learning to understand new modifications in genetics? Is it able to engineer new results? So generative AI is the idea of trying to create new things. But if you're looking for the patterns in the data, then it's predictive AI. So it's probably a mixture of the two. I know that Google, I can't remember the name of it, health. There is a health model that Google have done that they are trying, I believe you can use yourself to do lots of things in the health space. So I can't remember what it's called, Faz, but do check it out. Is it called Health ML? I'm afraid I won't be able to search it up, but maybe if you reach out to me on LinkedIn afterwards, I'm Adam Hall, and I can get you that information. But yes, really good question. Obviously, if you're doing stuff in health, do rate your data. Make sure you've got ethical use for whatever you're doing it. Cool. I don't know what SPSS and Excel examples of ML. I don't know what SPSS stands for, I'm afraid. Owen, it's a good question. So reach out to me afterwards because these ones go over my head. Ah, look, Daryl's got the link for Applied AI Health. Yeah, do check that out. They're doing some amazing things. Google's research in health. I think it's phenomenal the way that they're contributing to the machine learning space around health. Okay, tools at hand that you can use to clean up your data. There is Google Sheets. OpenRefine is a good tool if you're trying to do things offline. So OpenRefine, you actually download onto your computer. So if you've got particularly sensitive data that you want to anonymize before you put it up into the cloud to run machine learning on, then OpenRefine will help you cleanse that data, convert it into different formats, and just get it ready for machine learning. But the really good one that I like to push people towards is Data Prep by Trifactor. You can find it in Google Cloud. It's really powerful, but if you're trying to anonymize things before it gets to Data Prep, then OpenRefine is your tool of choice. Oh, Naraj, how does it work at analyzing identical twins? Love that. Cool. Right, tools to hand. Other things. Do check out Kaggle. So if you're getting into doing machine learning and learning how to do machine learning, Kaggle is basically, I'm going to give it a slightly unpolished view. It is your Facebook, but for data science. It's a community of over 18 million users who have shared 339,000 public data sets that can show you how you can run machine learning on those data sets, or you can go and find data sets. So you can literally type in, give me tree density in the south of France, and you'll probably find a data set where somebody's recorded that, sent it into this, and said you've got open access to then train your own model should you want to do something. So that's cool. Do just search for Kaggle, and then you can explore data sets and also see how other people have analyzed that data set. You can literally work through their notebooks and run their machine learning processes. So do check that out. Genan, has Trifactor now Alteryx? I don't know. And if it has, then that would be fascinating to know. So I'll get the slides updated if it's changed in the last few minutes. The exciting thing about AI is things are changing on a weekly basis. So thank you very much for pointing that out, and I will check the source if that's changed. Okay, right. Now we've looked at defining what machine learning is. I've only got 15 minutes to show you how you might use it in business. So as a result, I am going to show you the stepping stones at utilizing AI in your business. It's a good sort of approach to doing things. So we'll start off with the first one. Try and use widely available AI-powered tools. Gemini, ChatGPT, Jasper, these are all really good tools, and most of them you would just copy some text, for example, and paste it into Gemini. Particularly powerful if you're for example, wanting to create, a sales call customized script so that you can use that with your sales team. You can ask Gemini, please, can you draft a customized script for me during my sales calls with a prospect? Make it last about 30 minutes and have points in the conversation where I can tell them about my product. You would type that into Gemini and it would give you a large output on the page. Now, this is a tool that you would use as a one-off. It's kind of like you're utilizing it. You then interpret the results and then you do something with that information. Good example of somebody who used these tools, Break Bottle. So Johnny Cotton is the founder of Break Bottle. He designed a innovative water bottle that opens from the middle. It allows you to easily clean it, but he created that business mostly on his own. He used free open tools like Gemini and ChatGPT to help him with his content creation and create a Kickstarter campaign so that he could really boost his business. So he was using these tools to help him make sense of the business idea, to create content for the website, to send out emails. But all of this he was kind of doing manually, copying into a tool, getting the result, and then copying it back and putting it on a website, for example. So that's the first stepping stone. So if you are using ChatGPT or Gemini in your free time, then this is probably the level you're at today. The next level up from that is to use a model as a service or a pre-trained model. So this is where you would be interfacing with what's called an API, which is an application programming interface. This would connect your website, for example, to a service that's provided by a company who's actually already done machine learning. Rather than talk about it, I might switch over to a quick demo. So the Google Vision AI demo. So as you can see, this is the Google Cloud Vision API page. So this tells you how to integrate the API into your website, but I'm going to show you an example of what the API does. What I'm going to do is upload an image. As you can see, the image is uploading. Ooh, I've got to tell it that I'm not a robot. So I agree, I am not a robot. And so, as you can see, this image is of the Lionesses, who are the England women's football team, a very successful football team, I will say. And that is it. It is just an image. However, just by uploading it into the API can tell us all sorts of information about the image that we haven't had to program ourselves. So it's telling us there's a 79% likelihood that this image was taken at Wembley Stadium. There's no metadata on the image that says this. It just knows this because the pixels look like it could be Wembley Stadium. Another thing the API allows us to do is it can spot all the faces, and not only spot the faces, but it can tell us what mood each of those faces are in. So for example, if we're the photo gifts company, we can tell where the people are smiling and where they're not. And maybe we can make a comedy message about the person who's not smiling as much as the others. It can do all sorts of other things, spotting all sorts of objects and logos and labels and text. I quite like the properties. So if I was a photo gift website, somebody uploaded this to for a mug, let's say, I might find the most unusual non-grey colour. In this case, it's this nice pink trousers here. And I've got the hex value that then I can send to use as a header text or an underline, or I don't know, the handle of the mug that we're going to send out. But the most powerful thing for me as a business owner who is accepting photos uploaded by the general public is to check if the photo has anything that I would rather not my staff were exposed to. So it can apply a safe search filter. So if the user uploads something that's particularly adult, let's say, it can just respond and say, are you sure that this photo doesn't violate our guidelines on what you're allowed to upload to our printers, which are manned by humans? Thank you very much. So it just gives me the ability to do amazing things that would normally take a lot of manual process and do it kind of automatically. So that's an API I can integrate with my website and just utilize the power of ML without having to program it myself. Cool. Excellent. I'll get to some more of these questions at the end. I can see there's some really good questions here. Going back to the slides, you can adapt an existing model using low or no code methods. considering things like AutoMLs in Vertex AI or Azure Machine Learning. A lot of these things you can actually find an existing model and make changes to that model. So a great example of this, Wendy's. So Wendy's were improving the automation of how orders were taken through their drive-through. And what they did is they actually created an experience that used a lot of the foundational large language models and built on them so that you could actually have an automated contact with a box, but the box was literally AI running behind the scenes. So it could understand all the business rules, the logic for the conversation and the guardrails to make sure that the person wasn't just deferring and having a nice conversation with one of these chatbots. But it created a really novel and interesting way of ordering through the system, which I think is quite cool. Another example of using existing models. So Zoological Society London teamed up with Network Rail and they captured 35,000 data files, which included 3,000 hours of audio and around 33 acoustic monitors around South London during 2022. And they were listening out for line-side habitats. So they actually compared the data that they were capturing to something called BirdNet, BatDetect, and CityNet, which are all pre-trained machine learning models. And based on those patterns in the data, they could work out what sort of things were making noises. You know, does this contain the noise of a bat or a bird? Is it a endangered species? And what's the confidence level? So all of these things helped them actually map out a lot about the wildlife habitats in a way that they could never do before. And this was thanks to using notebooks like those seen in Kaggle, and lots of data scientists could then download this data and rapidly prototype and test different machine learning pipelines to get a better sense of what was going on. So a really good example of using existing models, combining them with other bits like new sounds and other models to really get an amazing view on what was going on in the area. And the last thing you could do is you could consider building your own model from scratch. So purely training your model yourself. For this, you would need lots of data scientists. You would need to get hardware in the server space. There'd be a lot of energy costs. I tried to defer companies from doing this unless they can answer these questions. One, do you have a living data set big enough to train the data? I mean, it can cost tens of thousands, if not up to millions of pounds to do some of these larger training sessions. So will you be able to make your money back? Will this system be a differentiator to your competitors? If your competitors have already built this, it might not serve as a useful service to create. And then another question is, would your competitors buy this as a service from you? So if you can boldly answer yes to all of these questions, not only do you have a case to build, but you're probably already on that journey. But I would say if you're not there yet, then do go through the other stages. Absolutely, you need to have experience of utilizing and merging other models together before you get to training your own model yourself. Oh, okay, cool, excellent. Well, a quick summary of what we've learned, because I've been talking a lot over the last hour. But machine learning can learn how to make useful predictions, classify or create using data. You can actually get lots of machine learning models. They can be very resource intensive to build, but there are many options already made and available for you to manage. And make sure that machine learning is well suited to the problem you're trying to solve. Do try and optimize your non-machine learning solution first. Other great areas that you can go, and I can see a few people have been asking about, how do I get a certification or where do I go next? Well, the thing that I will shout out to everybody is the third one on this, the Google Machine Learning Crash Course is amazing. It has 30 exercises, 25 lessons and lectures from Google researchers themselves. So check out the Machine Learning Crash Course if you want to go through really deep into that process. For an aspiring data scientist, what are the different no, sorry, how can you stand out as a data scientist in the job market? I think that's very hard. I think it is a very it's a massive area right now. It's kind of one of those bubble phases. How you stand out? Maybe use AI to make yourself stand out. But places like Kaggle, you can show what sort of reputation that you have. So sharing notebooks and being present and sharing your knowledge with the community will make you more reputable. So hopefully that can help you. What are the core packages with Python would you suggest? So Hashim, that's a really good question. I like to, Pandas AI, sorry, Pandas is a really good tool for manipulating and using data sets and sort of merging data sets together. There's another package called Pandas AI, which kind of allows you to do what Pandas does, but almost like a chatbot experience. So if you've used Pandas in the past, then have a look at Pandas AI. But once again, there's always new Python packages coming out, so play with them. The ones that you'll see on Kaggle are very much in use. Cool, excellent, and thank you so much for all these questions. I really hope you enjoyed the session, and we want to know what you think, because all data helps us improve this for other people. So do scan in the QR code. Let us know how we've done today. Daryl, thank you so much for answering so many of these questions in the chat. It's been awesome having Daryl. Thank you all so much for getting all the answers right and being so communicative. It really is great. So companies like, right, yeah, exactly. It's all about arming the people with the ability to then do the data processing. So selling ML chips is what a lot of these companies are wanting to do. Cool, excellent. It's been lovely to have you all. Do reach out to me on LinkedIn if you have further questions. My name's Adam Hall, and I hope you all have a really fantastic afternoon. Thanks, everyone. Bye.